Voyagers, everyone's favorite space probes, are back in the headlines, and we almost completely lost contact with Voyager 1 recently. On December 12, 2023, NASA reported that Voyager 1's flight data system, consisting of 3 onboard computers, began sending meaningless binary data to Earth. Engineers knew the probe was still operational because they could still send signals to it, but it was clear something was wrong. NASA's first attempt to fix the issue was to reboot the system, but that didn't work, and the probe continued to talk nonsense. After months of trying every trick in the book, NASA engineers finally found a solution. But before we dive into how they resolved the issue, let's take a closer look at the Voyager 1 probe and see how the engineering team managed to fix the problem. First of all, it's truly astonishing that the Voyager 1 and 2 probes have been traveling through space for nearly 47 years. NASA is doing everything possible to gather as much data from these probes as they can, hoping they'll still be operational by their 50th anniversary. Voyager 2 was launched on August 20, 1977, and Voyager 1 on September 5, 1977, making them the oldest active space probes. One of the most remarkable things about the Voyager probes is that they were only designed to last for 4 years. When Voyager 1's communication glitch first occurred, NASA engineers thought this could be the end of their connection with the probe. It was a very tense situation. They said, after all its achievements and experiences, we don't want to lose communication with the probe. Voyager 1 is an incredibly important spacecraft and has achieved some truly remarkable feats. Calling it a scientific legend would be an understatement. It discovered that Io, one of Jupiter's moons, isn't just a dead rock, but a supervolcanic world. The colored image of a volcano erupting into space left everyone in awe and was a huge surprise for NASA scientists. Also, this breathtaking image of Saturn captured by Voyager 1 amazed everyone. The images weren't just incredible. The probe also discovered that Titan, Saturn's largest moon, might have liquid water on its surface, and these are just a few of its many discoveries. So, what happened to Voyager 1, and why did the spacecraft stop communicating normally? A critical system had failed. Voyager 1's flight data system is a fundamental component that allows the spacecraft to operate independently during its deep space journey, and right now, the probe is an astounding 15.5 billion miles from Earth. The fact that we can still communicate with it is an incredible achievement, but there's an even more astonishing reason why this is possible, which I'll explain shortly. But first, let's return to the malfunction. Voyager 1's flight data system consists of various components that work together to manage the spacecraft's operations. This system includes the central computer, data storage units, command interface, and telemetry systems. The Command and Data Subsystem, CDS, Voyager 1's main computer, processes commands sent from Earth and manages the spacecraft's functions. If you're not familiar with the computers on the Voyagers, here's something you'll want to know. Voyager 1's computer system is extremely primitive by modern standards. The CDS has only 68 KB of memory and operates at a mere 88 kHz processing speed, which means it can execute about 8,000 instructions or cycles per second. In comparison, a modern central processing unit, CPU, with a 3 GHz clock speed can perform 3 billion cycles per second. And most smartphones today have 32 GB of memory. To put this storage difference into perspective, it's like comparing a cup with 68 drops of water to 32 Olympic-sized swimming pools full of water. The Flight Data System, FDS, that failed is a critical component responsible for managing and processing the data collected throughout the spacecraft's mission. The primary purpose of the FDS is to gather, process, and transmit the scientific data collected by Voyager 1's instruments and experiments back to Earth. It functions like the spacecraft's central nervous system, coordinating its various subsystems and ensuring smooth operation throughout its journey. After months of trying to figure out what went wrong, NASA engineers discovered that approximately 3% of the FDS memory had been corrupted. This malfunction might have been caused by charged particles in deep space or simply due to aging. The engineers couldn't repair the chip, so they reprogrammed the corrupted code by spreading it across the backup sections of the FDS memory. The first correction was sent to the Voyager 1 probe on April 18th, and because it had to travel a total of 30 billion miles to reach the spacecraft and return, it took nearly 2 full days for the NASA team to receive a response from the probe. However, on April 20th, 2024, NASA received a response with a huge sigh of relief, indicating that the correction had worked. Now, the engineers will have to spend the coming weeks rewriting the remaining missing codes for the flight data system. These commands will restore the probe's ability to send more critical scientific data back home. This isn't the first time the probes have encountered issues. The harsh environment of space has taken its toll on Voyager 1 and 2 over the long years. Communication with Voyager 2 was lost in August 2023, and engineers thought they might never hear from the probe again, but contact was re-established a few days later. Due to their extended time in space, NASA engineers have had to shut down some systems to conserve power. Voyager 1 is currently operating 4 out of its 10 instruments, while Voyager 2 is operating 5 out of 10. To save power, NASA engineers have shut down heaters and other systems to preserve key communication points, such as the high-gain antennas. The instruments that remain active include magnetometers and low-field magnetometers. These instruments measure the magnetic fields of the Sun and outer planets. One of the most significant discoveries from this instrument occurred in 2015, when the spacecraft found that even beyond the heliosphere's outer edge, a boundary that acts like the surface of the bubble surrounding our solar system. The solar winds could still influence the magnetic field of the charged particles they encountered. The low-energy charged particle instruments are still active on both probes. These instruments helped researchers identify the heliosphere boundary following intense solar activity in 1993. The hydrogen thrusters are also still active on both spacecraft, which help maneuver the probes and keep them warm. Each probe is also equipped with a micrometeoroid shield to protect their instruments from dust and small particles. Another important instrument still functioning is the optical calibration target, which helps calibrate the charged particle instruments on both probes. During their long journeys through deep space, the Voyagers have been pointed at the target plaques countless times for calibration. Other instruments are turned off, with some having been inactive for decades to conserve power. In addition to the instruments, the probe's radioisotope thermoelectric generators are also present. These generators use plutonium-238 to power and keep the probe warm, extending their missions for such a long duration. However, these generators are gradually weakening and will eventually stop completely. This could bring an end to the Voyager missions sooner than expected. Yet even if the probes become silent one day, it does not mean they will become useless to us. Remember, both spacecraft carry a message from Earth for any advanced civilizations that might find them in space. The Voyager Golden Records are phonograph records placed on each Voyager spacecraft. These records are designed to provide a snapshot of Earth and its inhabitants to any potential extraterrestrial intelligences that may discover the probe in the distant future. The records contain a variety of natural sounds from Earth, such as bird songs and the sounds of ocean waves. They also include greetings in 55 languages and musical pieces from different cultures, including Bach's Brandenburg Concerto No. 2, Beethoven's Fifth Symphony, and Chuck Berry's Johnny B. Good. Additionally, the records are encoded in analog format and contain 116 images depicting various aspects of life on Earth, including landscapes, animals, human anatomy, and scientific diagrams. It is worth noting that the content of the records was curated by a committee led by the renowned astronomer and science communicator Carl Sagan. The records were crafted from gold-plated copper, designed to withstand billions of years of space travel. Each record is engraved with playback instructions, including details on how to create a stylus and cartridge. Additionally, there is a diagram showing the Sun's position relative to 14 pulsars, which could be used to determine the spacecraft's origin. In case of hostile extraterrestrials, this information would guide them on how to reach our planet. The primary purpose of the Golden Records is to convey a message of goodwill from humanity to any extraterrestrial beings that might encounter them. However, we hope this does not happen anytime soon. Now, let me remind you of something incredible. Despite both probes being over 15 billion miles away, we can still communicate with them. Voyager 1 is moving away from us at about 38,000 miles per hour, while Voyager 2 is traveling at about 35,000 miles per hour. But here's an interesting fact you may not know. For part of each year, as Earth orbits the Sun, Our planet moves towards both spacecraft faster than they are moving away from us. Yes, you heard that right. Earth is approaching the spacecraft at a speed of 67,000 miles per hour in its orbit. This means the distance to Earth temporarily decreases. Their outward journey remains unchanged. It is our movement that changes. Both Voyager probes continue their mission to explore interstellar space and send valuable scientific data back to Earth. Aside from the effects of solar wind, they remain the farthest human-made objects operating in interstellar space. These probes are truly a testament to the brilliance of human imagination. That's all for today. However, stay tuned for more updates about Voyager. If you want to hear more about the discoveries made by these incredible probes, let us know in the comments. Thank you for watching.